There are nights when the sky looks less like a dome and more like a conversation written in cold fire. And tonight the voice is an object falling into focus with such poise and speed that it feels as if the universe has chosen articulation over silence. It began as a tremor in the data, time-stamped, cross-checked, and then elevated to significance. An interstellar visitor flagged by the Asteroid Terrestrial Impact Last Alert System 3I Atlas. The designation alone carries a history. 1I Oumuamua, a shard of strangeness in 2017, and 2I Borisov, a more classical cometary wanderer in 2019. But 3I is a different kind of sentence. Its path is unmistakably hyperbolic, a precise escape curve that cannot be bound by the sun's gravity. Its inbound speed, the excess velocity at infinity, is the native dialect of another star system, around 25 to 35 kilometers per second, depending on the epoch of fit, too fast to be a child of the Oort cloud drifting home. For weeks, telescopes across the globe share custody of the object, passing it from dusk to dawn, stitching together an orbit solution that hardens from rumor into ephemeris. And as the arc length grows, you can almost feel the data acquire personality. The visitor is small but bright, muted in color, composed of something that diffuses sunlight without giving astronomers the usual inventory of cometary signatures. It is the kind of thing that makes you think about the lineage of worlds, how planets train their fragments and flake their crusts, how a civilization might sand a surface until what remains is function and intent. Under the scrutiny of photometry, 3I Atlas behaves like a riddle whose answer is thinner than rock and louder than dust. Its light curve, that faint heartbeat of rotation, refuses to settle into a simple story. Amplitudes rise and fall with phase angle, suggesting an elongated shape or a highly reflective sur, face that flickers as it tumbles. Broadband colors lean neutral to slightly reddish, the sort of tone you might expect from complex organics or space-weathered ices, yet spectroscopy returns the cosmic equivalent of a shrug. Few narrow features, little that resembles the breath of water or carbon monoxide from a standard comet. Thermal models imply a surface that does not warm as efficiently as a dense boulder, as if what we're seeing has a high area-to-mass ratio, a sheeted body, a fractal fluff, or a layered crust that traps heat poorly and accelerates well. Radar attempts prove inconclusive, either from distance or geometry, and so the imagination must stand in for resolution. Under the relentless triangulation of observatories, the positional residuals, the tiny differences between where gravity says it should be and where it actually is, begin to drift with a coherence that suggests a gentle push. It is subtle, real, and consistent enough to survive the skeptic's first barrage of calibration checks, a non-gravitational acceleration. You can quantify that push, call it A1 if outward, A2 if tangential, and A3 if normal to the orbital plane, and the fit improves. The outstanding fact, the one that turns curiosity into a challenge, is that the acceleration appears roughly proportional to the inverse square of the distance from the sun, as though it were a leaf being urged outward by light itself. For comets, the usual culprit is outgassing. Ices sublimate, jets recoil, dust sprays, and the nucleus responds with slight but measurable course corrections. But 3I Atlas refuses to grow a coma bright enough to justify the impulse it exhibits. No broad coronas, no tail worth boasting about, no detectable release of volatiles at levels that would match the acceleration. Radiation pressure, that photon wind that barely matters to boulders but dominates the fate of motes, begins to look like a prime suspect. If 3I has a high area-to-mass ratio, think a porous aggregate with bulk density like aerogel, or a shard of something thin and wide, then sunlight itself could be steering it. The mathematics is mercilessly elegant. Flux falls as 1 over r squared. So does the inferred push. A sail would do it. So would a body of improbable fluff, a snowflake the size of a house hardened by vacuum into tenacity. Between the known and the hinted lies a corridor of possibilities that feel both audacious and cautious, a natural relic shaped by violence and time, or an artifact whose outline has been obscured by distance and modesty. Speculation proliferates where data is sparse, yet the better kind of speculation is anchored by physics that fights back. Hydrogen icebergs were once proposed for Oumuamua, sublimation so clean it leaves no dust, no familiar volatile signatures, but interstellar travel would likely sandblast such a body into invisibility long before it reached our sun. Nitrogen ice, shaved from the crust of a distant Pluto analog, would sublimate more stubbornly and might mimic the right photometric behavior, but cosmic rays and micrometeor Oid collisions remain severe creditors on that hypothesis, demanding mass that the object may no longer possess. There are fluffy aggregates with power law porosity that can survive impacts by dissipating energy through fractal pathways, and these could deliver the necessary area-to-mass ratio while hiding their chemistry in an architecture of voids. Then there is the possibility that brushes against science fiction, but refuses to be excluded: engineered thinness. A light sail, reflective, resilient, puckered by micrometeorites, yet still coherent, would listen to sunlight as a captain listens to the wind. It would be difficult to build, yet not impossible. Difficult to preserve, yet not unthinkable if the builder's timescales dwarf our empires. Between ice and sail stands an exotic middle ground, a layered laminate of organic-rich foams and mineral films, a natural metamaterial born in the foundries of colliding worlds. The universe is a good engineer, and time is the best laboratory. We should be humble about what rocks can learn to be. Timing turns the curious into the uncanny. 3I Atlas arrives as the sun's magnetic breath swells toward a crest, inflating the heliosphere and stirring the solar wind into complex weather. Coronal mass ejections march across the inner system as if the star were clearing its throat for emphasis. Earth's best viewing windows, optimized by the geometry of twilight and the moon's phase, are punctuated by weeks when key southern instruments are down for upgrades or wrestling with weather tall enough to silence domes. The thread of data must hop continents, and each handoff introduces the human element: cues, priorities, fatigue. In the background, meteor networks listen for the soft patter of interstellar seeds ablating in our air, hoping to correlate some tiny shower that whispers of 3I's deeper composition. Instead, the counts remain stubbornly terrestrial. Coincidence is the commonest conspiracy, and yet the cadence is dramatic. A visitor that asks for attention at moments when the sky is noisier than usual and our machines are distracted. A poet might call it choreography. A physicist calls it a sampling bias amplified by our hunger for pattern. But even the physicist will admit that the best mysteries often arrive with a soundtrack composed by chance. Gravity is an honest negotiator and an exacting bookkeeper. 3I Atlas glides down the sun's potential well, converts altitude into speed, and twists its path under the exacting calculus of conic sections. There is no close pass with Jupiter to muddy the tale, no catastrophic planetary encounter to hide behind uncertainties. This is a clean, sun-centric slingshot, a near-parabolic dive bent just enough to ensure it will never return. Tisserand parameters relative to Jupiter mark it as an outsider. In a different life, with a slightly different speed, it could have been a long-period comet. As it arcs past perihelion, the fitted residuals continue to require the gentle, sunward proportional nudge that set theorists rumbling. You can map the non-gravitational vector over time and watch it flex with phase angle. Hinting that the effective sail area changes as the object rotates, almost as if vanes were catching light at some orientations and hiding at others. The orbit determination centers fold this into their models, and the uncertainty ellipses tighten, then breathe, then tighten again. Through it all, Newton's gravity holds the melody, while a fainter harmony, born of photons, keeps time in the margins. Then comes the blackout, the period of conjunction when the sun plays the censor, and even our best instruments must avert their gaze. We had learned to fear such gaps from previous visitors. Oumuamua's vanishing act, Borisov's disintegration, And 3I makes the interval feel personal. Papers go out for review with caveats the size of constellations, pending further observation, provisional acceleration, models subject to revision. In the rumor mills where the internet synthesizes certainty out of impatience, the gap becomes a theater. Some whisper of suppressed frames, of private observatories capturing silhouettes that institutions refuse to share. Others imagine a probe making minute course corrections that no natural object could execute. But the slower story is truer. Calibration pipelines catch up, ancillary data sets are reconciled, and the solar background's glare is given the painstaking treatment it demands. In the void between what we think we know and what we can finally test, suspicion grows easily. The antidote is the patient cruelty of measurement. When 3I reemerges from the sun's tyranny, you can feel the collective exhale across observatories separated by oceans and languages. The acceleration remains small and stubborn, the sign of a phenomenon that will not be banished by the return of photons to our sensors. If the push is real and governed by light, then 3I Atlas becomes a practical seminar in propulsion. Sunlight is free but faint, a pressure measured in micronewtons per square meter at Earth's orbit. And yet it can build empires if your craft is thin enough and patient. We have dreamed of sails for a century and built them in this one. Mylar kites unfurled in low Earth orbit, solar sails that tack across the subtle winds of photons, concepts like breakthrough star shot that propose wafer-thin probes kicked to a fraction of light speed by ground-based lasers. 3I is the ghost of a future we can confirm with math, whether or not it is a child of our technology. If natural, it tells us that high area-to-mass bodies can survive gulfs of radiation and dust, suggesting architectures for probes that learn resilience from geology. If engineered, it argues that civilizations older than our species might treat interstellar distances as archipelagos connected by steady breezes. In either case, our policy choices in exploration shift. We prioritize rapid response missions capable of leaping off the pad to meet interstellar transients mid-trajectory. We refine onboard autonomy and laminar aerodynamics for vacuum. We invest in heliophysics because the sun's moods become our navigation charts. The T. Emeline compresses. Discovery no longer means a decade of contemplation before a decade of building. Discovery means the clock is already running. There is also the quiet revolution that occurs in how we search. All sky surveys sharpen from mere guardians against impact into cartographers of the interstellar through traffic. You can imagine a network, call it Interstellar Sentinel, distributed across latitudes, some robotic, some human-tended, many wedded to machine learning filters trained not just to find moving points, but to classify the tone of their motion. When a visitor is flagged, interceptors pre-positioned in heliocentric orbits wake and pivot, their fuel budgets optimized for radial sprints rather than leisurely transfers. A small swarm approaches, one probe to image silhouette at close range, one to sniff the wake for molecules, one to measure the momentum exchange with sunlight by flying in formation and watching the spacing breathe with rotation. Even a failure would be an education, a map of how not to chase a ghost through geometry. Success would deliver the first high-resolution portrait of an interstellar fragment or flyer, a picture worth a library of argument. Beyond the purely scientific, there is a cultural shift. The public begins to see the sky as a place where messages might arrive unannounced and unaddressed, and the appropriate response is neither panic nor worship, but attention. Of course, the mind keeps circling the possibility that refuses to be comfortably natural. If 3I Atlas were a probe, an artifact of intention rather than accident, what intentions would match its silence? A derelict can drift with dignity, a sail can tear and still carry shape, a messenger can arrive centuries after its sender has turned to dust. Perhaps the purpose is endurance rather than communication. A small testament in the ledger of the galaxy that minds can harden matter into meaning, and meaning can cross cold, empty distances without pleading for an audience. Or perhaps this is reconnaissance by presence alone, a test of our attentional bandwidth, and our grace under ambiguity. There is a humility demanded by such speculation, the recognition that even if an answer were true, we might not yet possess the interpretive instruments to wield it. At the same time, there is a confidence born of physics. If a thing accelerates, we can measure. If it reflects, we can model. If it persists, we can meet it. Wonder does not preclude rigor. Wonder fuels the will to apply it. So we return to the data, to light curves and thermal fits, to dynamical models that weave gravity and radiation into a single tapestry. We revisit upper limits on outgassing with colder assumptions, push spectrographs to more patient exposures, and hunt for transient absorption lines that might mark exotic ices evaporating in shy quantities. We compare the phase angle dependence of brightness with databases of known bodies, seeking kinships that could demote the extraordinary to the instructively rare. Meanwhile, theorists cultivate families of models, fractal aggregates, WITs. The porosities tuned to survive micrometeorite fluxes, spin states that align reflective planes with sunlight just often enough to explain the vector of the push, composite materials that nature might fabricate in impact plumes and cooling disks. As the arc extends and the signal-to-noise steadies, some branches of the possibility tree will wither. What remains will be less poetic but more astonishing. A constrained catalog of ways that matter can conspire with light to write its own itinerary. And in the end, by which I mean the end of this chapter, not the story, we will let 3I Atlas go. It will quit the districts of the planets with unspent velocity, carrying our questions like pollen. We will not chase this one. We were not ready. But we will build for the next, because the universe has shown us a syllabus and we have enrolled. We will lay down heliocentric depots of fuel and attention. We will teach our probes to sleep lightly and launch fast. We will keep time against the sun's weather, not to fear it, but to ride it. And when the fourth interstellar visitor writes its line in our sky, we will be there with machines and minds tuned to hear the grammar of its motion, to test whether acceleration can ever be anything other than natural, because once we can draw that border with confidence, either side of it is civilization. On one side, we learn the deep crafts of geology and ice, the strategies matter uses to survive the dark. On the other, we glimpse the signatures of will written into orbit. Both sides are invitations. For now, let the record show that a small body came from another sun, slipped through the bright and crowded middle of our system, and then, very gently, did something more than fall. The slopes of its trajectory contained a whisper. Our instruments, our patience, and our courage to consider audacious hypotheses form the ear. Between those two, an understanding is beginning to grow, that the solar system is not merely a home, but a harbor, and harbors have traffic. The next arrivals may be boulders or boats. Either way, we will be ready to greet them, not with superstition, but with instruments sharpened into listening. And if someday a true sail crosses our sky, catching the sun with curves that cannot be mistakable, it will not surprise us that we recognized it first in a modest acceleration, in a difference between prediction and place, in a conversation conducted at the speed of light across the metric of space.